Hi guys, welcome to my YouTube channel. Just a quick introduction. I'm Himanshu, working as a software developer in an MNC from more than 3 years now. So, how many of you guys know how to write extensible code from college only? I probably guess the answer will be no for most of us, but there will be a cohort of people will say yes. But again, when we start thinking about when we started as our journey with any of our company, where we have to work on a code, writing a code that will go to a production, and there will be an enhancement of that code. We might have felt that we are under equipped with the technical knowledge that we have gained. The same was from my side as well. Due to this problem, I was struggling with writing a good code. There were a lot of reviewer comments that were there in my code reviews, and that caused me, like, there were the multiple delays in the project that caused delay in the project. So just to overcome that problem, I reached out to some of my seniors and they were able to help me out that I am missing on to a key concept which is called design patterns, which help us to reduce these kinds of anomalies while doing the low level design of a system. So now a quick question that would have come into your head is, so what are these design patterns? Design pattern is just a general reusable solution to a commonly occurring problem within a given context in a software design. Just if you can think about it, it is just a way or to templatize a particular type of a work that you can do with a particular type of a solution. So let's say you need to do 2 plus 2, right? Just a basic example in mathematics. So let's say if you have to do 2 plus 2, what in childhood we used to do, I used to uh, add like we used to stick two sticks, and then again two sticks, and then we count that from initial zero, that okay, it becomes four sticks now. So this kind of activity that we used to do, that was a formalized activity that we have in mind. So you can think about it as this only. So it is not a finalized design that can be transformed directly to a source or a machine code, but rather than it is a very good description or a template to how to solve a particular problem that can be used in many different solutions. Patterns majorly formalize best practices that a programmer use to solve a common problem given a in a given situation. Design patterns are majorly classified into three categories: creational, structural, and behavioral patterns. Creational patterns, as we have currently guessed it out, they are the patterns that are used to create object in a much more flexible and a reusable way, whereas with a structural pattern, they help us to organize the objects uh, into a larger structure. And for the behavioral pattern, they help us to communicate and interact with each other. So there are many examples or many benefits of design patterns. I have collated a few out of it. So top four of them are: they help the developers to write more usable and maintainable code. They also help the developer to avoid common design pitfalls like maintainability, resilience of a program is going down, or in your design it's not there. By using some of the design pattern, you can get the reusability of the entire code. Then they also provide a common language for a developer to communicate about their designs. They usually helps the developer to communicate much better. So let's say if I have to explain you, like, okay, do this, it will be a much difficult job for me to uh, suggest you, like, okay, do, like, create a class, create an interface, inherit this, extend this. So it will be a very tedious job for me as well. So rather than, I will just take a name of a pattern in which you will picturize the perfect example for that. So where I will come into picture in this is I will during my initial days I've also struggled for some of the educative content of these kinds of patterns designs. So I struggled a lot for that. I was able to find some of the good, but the collation was not complete. So I will try to collate all of these for you guys so that at least we have a very good set of videos so that we can easily refer them whenever we want. So with every pattern, I will make sure I give you a gist of it in the starting only. Then we will look at the problem statement, solution, definition, final definition, and the UML with some of the like demo code of it. So are you guys ready for your first design pattern? Great. So let's get started with the strategy pattern first. So uh, just how you guys will remember the okay, what is a strategy pattern? A strategy pattern is composition should always be preferred over interference. So this is the basic example of strategy pattern. Here, when I say composition is always prefer above inheritance, is that we should always use composite classes rather than interfaces. Okay. You will get more clarity when we discuss the problem statement, when we go ahead with the the solution, how we will be solving it, and with the UML diagram, and you will get a very good picture. So to start with the problem statement, so let's say in an architecture we inherit a class. All the behaviors get transmitted or transformed from the parent class to a child class when we inherit it. Also, the implementation is prone to much of duplication. Let's say if I have two functions in the interface, there can be a chance that one function is common with the end of different classes, and the second function used to change again and again. So in this case implementation, we also face the similar problem. So but just to be on a very high level of the things, I will just introduce you with the uh, a problem statement UML diagram. So just consider that this is a duck interface. Okay, in this duck interface we have three functions, sorry. Display, fly, and let's say quack. Cool. This is a interface. I'm just denoting it by the end so that you guys have a much clear picture for that. Let's say there are three different kind of ducks. One is A duck, one is B duck, and I guess you would have till now to deciphered what is the name of the third duck. Correct. Yeah, it's C duck. So let's say this inherit the duck interface, all these three. So we will write display, quack, and fly for each of the duck. Cool. And we will implement that. And just to be on a very safer side, let's say currently each of these three ducks has different implementation. Then we are good, right? We don't have anything to worry about because each implementation that we are doing is a unique implementation. But let's just assume the fly method of A duck and the fly method of B duck is similar. When I say similar, let's say the implementation of the fly method of A and B duck is similar. So just to be on a safer side, let's just assume that fly duck it prints system dot out dot print. It prints uh, fly. And then there is one more implementation of, let's say, a C duck that cannot fly, and it will be system.out.println. It will be no fly. Now, just a basic assumption that A duck and B duck can fly and C duck cannot fly. So what will be the use case in this particular example if you see? So we need to write this code 2 times, right? And this code will be 1 time. So now you see that, okay, this particular code could have been a reusable code in some of the instances, and we can easily reuse it in some of the other use cases as well. So let's say if my use case increases from, let's say, these 3 type of ducks to 8 type of ducks, then the permutation of having these type of smaller use cases will be much higher, right? So just to solve that problem, again, just a vague example in the above scenario, you will be saying that, okay, this can be easily done or solved by using an abstract class, right? Yeah, you are correct. This particular problem can be solved by the abstract class, because in this particular case we will easily abstract we will use the we will use the this method, fly method, as a abstract method, or just to be on a very simple scale, we will implement this into the base class, and then while extending it to this fly method, we will override it, right? This is what you wanted to say. But like, see, let's say there we have 8 use cases, right? This cannot be even a good extensible solution, right? It won't solve our the major problem that we are having in this particular case, right? So to make it like more generic, if we want multiple solutions or multiple ways to solve our problem, we need to extract the behaviors out of it. So in the above example, let's say if I figure out there are 3 behaviors, okay, one behavior is quack, one behavior is fly, and the third behavior that I am talking about is display. So these are the behaviors that can change. Apart from that, a duck is an interface, and it can have a child classes, that A duck, B duck, or C duck, right? So now, just coming back to this example again, like what we were initially thinking, to solve this problem we usually try to extract out more granular behaviors. So if you see, we have extracted out all the 3 granular behaviors. In this case, we are usually concreting the underlying behavior or a set of algorithm that can be extended easily to the different cases. Okay, so let's say in this, if I have a, let's say in the above example only, if I have a fly behavior and a no fly behavior, right, then it can be easily extended into my solution of, let's say, A duck has fly behavior, B duck has fly behavior, whereas C duck has no fly behavior. So just to be on a like a very safer end, going ahead with the how these behaviors will be different. So like in just interest of time, so that I do also want to be very precise with it, let's just have a very unique example of having uh, just have a duck as an interface. Okay, and in this duck, let's just inculcate fly and quack as behaviors, not as a function. These are the behaviors. Like when I'm writing this, ideally it shouldn't be this also, to be very honest. uh, so this shouldn't be the use case here. So it is fly behavior and a quack behavior. So these be, when I say a behavior, these are the properties of this particular duck class or the duck interface. Now I will have like multiple ducks that are extending this or inheriting this class. So just to say that, let's say we have a duck again, and we now comes again the B duck. I think the position of these ducks are changed, but I don't really think the functionality will change of these stuff. So and then we will definitely we need to have a hazard relationship, and in this hazard relationship this fly behavior will be implemented. So this fly is again the fly interface or the behavioral interfaces. So let's say fly and quack interface we have. Okay, in this fly and quack interface we have a fly function, and in this we have a quack function. So let's say these are the interfaces, and now I need to extend or have a fly behavior, okay, or no fly behavior. So I will create two different classes, one class with the fly behavior, and let's say it will like it will implement inherited this class, and it will have a fly behavior, and then there will be a second class that will have a no fly behavior. And this class I can like if I want, I can directly inherit it while initializing these classes. So let's say this is fly, this is quack, I need no fly here, so I will inherit it no in I will inherit no fly, I will inherit let's say quack here. Okay, so if you see this particular example, we have easily we were able to solve this problem by implementing an like we are extracting out the behavior out of this. Okay, so so how we solve this problem now is we do composition of all the behavior, and then that can be inherited interfaces implementations to it classes. In this case if we want to extend the implementation of class a duck and b duck, we don't have to copy it each of the time, we will just inject it into the child class. All this behavior can be changed and can be used by using a injection. So now, like after reading this out, I am hoping that you guys are very clear with what a particular like what I'm trying to explain, how to extract out the compositions. So just to wrap everything or sum everything up, what we have learned is uh, the basic definition of a strategy pattern. So strategy pattern defines a family of algorithms then in that encapsulate each other and make it interchangeable. A strategy let the algorithm vary independently from clients to clients. So now, as I promised, I will be giving you a basic like a UML that can fit most probably, or that is a much more easier way to fit this out. So let's say I have a I behavior. When I am denoting something with I, that means it is an interface. I have a I behavior, and it has a run object. Okay, and let's say I have like there are two kind of implementation that are or two kind of behavior that are present for this run function. So just assume it as behave A and behave B. Okay, behave. Pardon me for my writing, right? Behave B. So it will be run method will be implemented here. Run method will be implemented here. There will be some like let's say it will be fast something like run fast. It will be run like run slow type of implementation here that will be there. Okay, and now we will have let's say a particular class that will a client that will inherit or inject. When I say inherit, it does not only mean the implement, it can inject. So this is a client, it will inject I behavior. Okay, and during the initial compile time I can initialize like what this behavior can be in this execute function. So let's say I can write behave equal to behave A. That can be a very easy extensible solution, right? So this is our first design pattern. Just to be on a very like a lighter note, I have coded it out as well. If you can see, I have a strategy pattern. I have, like, in this example what I have done, like, if I show you one of the, like, draw I major interface. Vehicle has three interfaces: vehicle interface, then class, both the classes are in both the classes, like car and bike, are inheriting the vehicle. Whereas where we have put anxiety on the color and the wheel, we have put anxiety. So color is an interface here which have a color string, set and getters are there. Whereas we have a red color, we have these implementations. For the blue color, we have its own implementation, whereas the same similar kind of implementation is done for the wheel strategy as well. And when in the vehicle, if you see, for a basic car implementation, we have just injected the correct type of colors, right? When I have just injected the wheels and the colors, I don't have to copy it out again at 8 different places. It will be easily done. So I think but this is a basic example that I can give. This is a very basic example just to explain you how to implement and how to have a behaviors intact. So if you see, when I say I have a behavior, the behaviors are here. The car has a behavior. When I say initially, let's say, just open a file of a vehicle, right? So vehicle has an interface which has a display method, but it does, like, for a behavior to get injected, the behaviors are getting injected in the car and the bike examples, so we can easily reuse that. So yeah, that's it from my side for today. I hope that you like this particular video, and like, it's just a basic uh, contribution that I could do in terms of what I have learned and what I will be like, and I will continue onto these kinds of videos for like, let's say, have a better clarity on other design patterns, and we will explore all of them. Uh, for today, I am like, thanks a lot for joining in. Please like, share, and subscribe the channel.